This video is going to introduce you to vectors. I am using the sample program from the Dawson textbook, Introduction to C++ through Game Programming, Chapter 4. And vectors are, it's a container like an array. It's one of the containers in the standard template library in C++. If you take a look at our pound includes, we have to use pound include vector, and that again is from the standard template library in C++. Vectors are very, very similar to arrays, except some of the behind the scenes work on allowing the size of the vector to grow and shrink and access the size and things like that are built in. So they are actually much more useful than straight up arrays. This particular example is going to create a string vector, and so you must use the keyword vector in front, bracket, string, inventory, and that's just going to set aside memory, and it's telling the computer that you want to use a container called a vector. There are other ways to create a vector, just so that you can see the syntax. You could create a string vector, and you could give it an initial size like we do with arrays, and you could use a constant variable in there, I believe, if you want. Actually, let's just try that real quick just to see if that works, because it might not work with a vector because of the fact that a vector can grow and shrink. But if I start a constant value of 10 and then I use that variable size inside the vector here, I want to see if it's going to allow me to do that or if it's going to scream at me. And it looks like it might allow me to do that. I'm going to go ahead and hit compile. It might take a moment to do that, but we'll see what happens. And so as long as we give it the size here, that is optional. And the thing is, most people don't do that because you can resize vectors as you go through the program, and it resizes automatically for you. However, if you do know that you're going to start with at least 10 things, then you might want to do that. So it worked creating it that way. So you can use a constant declarator and put it in here for size if you like. The other thing that you can do is I can declare a vector, and I can tell it that there is nothing in the vector to start with, and that would fill the entire vector with nothing. And then these items here would be added to the vector after that. So if we just take a glance and I use Control F5, you can see it's being filled with nothing, and then it gets filled with some other things afterwards. And so we'll take a look at how that works here in just a moment. A third thing you can do with vectors is you can actually declare a vector and fill it with another vector. So you could have vector and then inventory, and then you could declare it to another vector. So my stuff would be another vector. You would not use the size declarator at all because the computer would know on the fly how much is in my stuff, and it would automatically assign it to inventory. So that's vector string inventory my stuff. So you're sending that in as a parameter. I'm getting an error message here because I haven't declared my stuff as a vector. I'd have to declare that as a vector. It would have to look something like this: vector string my stuff, and then it should clear that up. So whatever I stored in my stuff would then be automatically created in vector. So it's actually kind of like copying over an array. And if you think about copying an array, when you copy an array, you have to copy element by element. So this would be a little bit more efficient. I'm going to delete those lines of code, and we're just going to look at the rest of the program. Vectors have built-in methods. The methods that are available for using a vector, some of them are in your PowerPoint for Chapter 8 in your Gaddis book. This first slide shows you how to define vectors, but the next one shows pushback, which is a function. It adds an element to a full array. And we have a size member, which gets the size of the vector no matter what size it is as it grows and it shrinks. We have a popback method, which removes the last element from the vector. And we have a clear method, and there's an empty method to check to see if the vector is empty. Those are the most frequently used vector methods. There are other ones that we could use, and you could look those up online if you need to. Going back to the program then, when I want to add an element to a vector, I use this pushback method. And so this particular example is going to put, it's like creating an array with 3 items in it, but it's a vector, sword, armor, and shield. And what's cool is I didn't have to tell it what size I needed, and as it grows, it's going to capture that size. So if I run this program, it's going to tell me that there are 3 items in that list initially. The other thing that's kind of cool about vectors is that you don't have to keep track of that constant variable size all the time and use that in your loop. You're able to access that size method right here. And so your for loops become initialized at 0. They go to less than size because you still have the off by 1 error, not error, but you still have the off by 1 that you have to consider, just like arrays. And then you can use the array syntax right here. So you are using the array brackets to manage or work with the vector elements. So it's kind of nice because you can treat it just like an array using the bracket notation, but it's an array that will basically grow and shrink. So if you take a look at that output, that's what's printed here, your items, sword, armor, shield. So it's showing you that sword, armor, and shield were added to the vector, and we didn't have to declare an initial size because vector sizes grow and shrink. So it says you have 3 items, it outputted 3 items. If we take a look at the rest of the code just to see how to work with some of the vector elements, you can treat the bracket notation just like you would an array. So I'm going to reassign the 0 position battle axe. So if we print that out again, you can see that sword was now traded in for a battle axe. You still have 3 items, but battle axe replaces what was in sword because I used an assignment statement. The next one, it says I'm going to take the name battle axe has 10 letters in it. So this particular example is finding the size of the first inventory item. So this is kind of like an example of an overloaded method where size on a vector gives you the size of the vector, size of a string gives you the size of a string. And the reason for that is behind the scenes, a string itself is just an array of characters or a vector of characters. So you can use that size feature on it because it's just a vector of characters. And so size happens to work to give you the length of the particular letters. If you count them, notice if it includes the space or not. Battle is B1, 2, 3, 4, 5, 6, 7 for the space, 8, 9, 10. So it includes the space when it counts those letters. That white space there, actually black space on that screen, is included in the character count. If I want to get rid of something, I have a couple of choices. One of them is I can do a pop back. A pop back removes the last item on the list. And so pop back, if I pop back, I now have only 2 items, battle axe on armor. You can see that shield was removed from the list. And we output it again. That was just to show you. And look right here, I only have 2 items on my list now, but we used inventory.size here, and it knew there were only 2 items versus up here when I used inventory.size, I had 3 items. I didn't have to change the code or anything because it knew automatically that the size had changed from 3 to 2. Last but not least, when you're working with vectors, you have to be careful because remember that C++ does not do any memory management and clean up after itself, so you have to clean house for it. So you have to clear the vector, and then if you want to double check to see if something has been cleared, you can check to see if the vector is empty. And here we were robbed of all of our possessions, and so you have nothing. So it verified that the vector was empty, and then there is nothing left in the vector. So the clear will clear out everything, and it leaves you then, you can check to see if something is empty to know whether or not you need to process it. Now, pop back is a way to remove an item from a vector, and I thought there might be another method where you could insert at a certain location, but I'll be honest, I might be confusing my Java right now with my C++. So at this point, we're going to stop the video. It has demonstrated how to create a vector. It has demonstrated how to add items to a vector. We have looked to see how to use the size operator to access the number of items in the vector, and then we use that size operator to print the vector. We have used pop back to remove an item from a vector. It shows the clear method, and it shows testing to see if a vector is empty or not. And the output again looks like this. So that is your introduction to vectors.